Hi everyone, my name is Kaushal. So today I am going to discuss about the RAG and GraphRag. So first of all, understand the RAG. What is the meaning of RAG? RAG. It means the retrieval augmented generation. What does it means? It means that this is a technique. It is a technique where the LLM first retrieve the information from your own data and then use that data for generating the answer. So, this is a technique. So, in this technique LLM first retrieve the information from your own data, whatever you have stored inside the vector DB, and after returning that data, it generates the answer. So, basic flow of this RAG is that first of all your document may be in the form of PDF, in the form of docs or something. So, whatever your document, it goes to the chunking techniques. We chunk the all the document on the basis of the word count, suppose 100 or 200 chunking. We chunk whole the database on this one. After that we do the embedding. Embedding means to convert your document data into the numerical forms. After that we store this embedding in vector DB. After that, whenever user going to produce the query, it retrieve the semantic search from the vector DB and return the result to LLM, and LLM produce the augmented answer. So, for example, suppose you have 100 PDFs of your company database, or you can say that some lease policy, you have 100, 2000, 100, any type of PDF. And so first we convert those PDF document into the embedding and store inside the vector DB, and after vector DB storing, whenever we user gives the query, that query first convert into the embedding, and that it goes inside the vector DB. It find out the top 3 or 4 similar answer on the basis of cosine similarity, and it will returns the embedding to the LLM, and after providing the LLM, it convert to the text, and text goes to the LLM and it will produce the augmented answer. So, this is the basic flow of the retrieval augmented generation RAG. So, now uh, then what is the use of the GraphRag? There is another type of the retrieval augmentation generation which is called the GraphRag. What does it means? It means that It extends the traditional RAG by using the knowledge graph to represent the relationship between the pieces of the information. So, in RAG we store the embedding into the vector DB, but in graph RAG we stores the information only as independent chunks, and that we represent as entities, and the whatever the relation between these entities we also store that relationship also. So, suppose example Priya is engineer. So, Priya is one entity and the engineer the job is another type of entity, and there is a relationship between the Priya and engineering. So, these information will be stored inside the GraphDB in the form of graphical representation of the relationships. So, whenever uh, user find out the query based on the relationship, then we will use the graph RAG. Suppose in the organization employee work work in, this is the relationship, in AI department, and there is relationship has skills Python. So, this whole information of the relationship will be stored inside the GraphDB. Employee is independent entity, department is independent entity, it will contains the data AI, and employee contains the employee database, and there is another entity, you can say the skill subjects, and there is relationship between the department and Python. So, whole information of relationship between these type is going to store inside the GraphDB database. So, in normal RAG system we can retrieve the chunk, suppose AI, Python or Priya, but it does not inherit understand the relationship between them. So, GraphDB such as the Neo4j explicitly store their relationships. So, GraphDB provides the more uh, accurate results whenever we are retrieving the informations in the form of relationships. So, now we are going to compare in the terms of the features. Suppose for RAG we use the main storage vector DB, but for graph RAG we use the knowledge graph, and in RAG we save the chunks, but in graph RAG we save the entities plus relationships. And for the RAG, whenever you are going to retrieval, it provides the result based on the semantic similarities, and whenever you use the retrieve the data from the GraphDB, it produces the data based on the graph relationships plus semantic retrieval. And multi-hop questions cannot be possible inside the RAG, but in graph RAG we can get the multi-hop questions. So, now example, suppose whenever we use the RAG, what is the Python, when we are going to retrieve from this statement. So, this statement provides the similarity document which is stored inside the vector DP. But with the help of GraphRag, we can also find out the information, suppose which AI employee know the Python. In RAG, the AI or employee of Python may be on different documents. So, we cannot find out the relationship between the AI employee and the Python subjects. But with the help of GraphRag, it is easily be retrievable because we store the relationships and the different entities. So, this is the basic difference between the RAG and GraphRag. Now, I am going to explain in this picture also, just see here. So, this is a GraphRag pipeline. User asks the questions, LLM generates the question to the cipher language. Cipher language is the language which is used inside the GraphRag. Uh, and in my project, I am using the Neo4j as a graph database. So, next step is it will check the guard checks, and after that Neo4 execute the cyber query, and it will returns the row, and that rows goes to the LLM, it generates the final answer and it will return to the users. So, this is difference. RAG is a technique where the LLM first retrieve the relevant information from the external source, and then uses the information to generate the accurate and up-to-date database. But in GraphRag is the form of RAG where the retrieval is done from the graph database like Neo4j instead of the document or vector index. You can say the vector DB. Graph stores the entity and their relationships. So, we can retrieve the connected and meaningful information with the help of GraphRag. Here the example, which employee knows the Python. So, it will generate this cipher query, match employee which has skills. This is a relationship as dot skills where as that name is called to Python, return that employee name. So, it will return that particular employee name. So, it will go to the two nodes, employee and skills, and there is a relation with the has skills. So, all these information has been stored inside the GraphDB. And whenever we find out the results like employee Priya Sharma, and that information is passed to the LLM, the final answer which is natural language Priya Sharma, and Sneh Iyer knows the Python. So, this is provides the better answer because it contains the relationship also. Now, next, why we use a graph instead of the vector search? Simply vector search embedding, find the semantically similar text document. Here, store the entity as a nodes and their connection as a relationship. And this is good for unstructured data like text, PDF or notes. Understand how things are connected. Does not explicitly understand the relationship between the entities. It can answer the complex traversal query. Next example, find the docs about the Python but does not know who knows the Python or which projects they work on. But here, find the employee who knows the Python and work on the project alpha in AI department. So this is the different cases. Whatever cases requires, we use that particular type of RAG. Note, what is the definition of the node inside a graph DB? Node represents the entity or object in real world. Suppose employee, department, and projects. These are the nodes. And relationship, what is the relationship between these entities? Suppose relationship type is working, work on, has skills. So suppose employee Priya Verma work in AI department, work on the project name of project alpha, and has the skill Python. So this type of information also stored in the GraphDB. Now properties are the key value information stored in the node or relationship. Suppose this is the node, it has contains the key and value. Name is this, role is this. Name is this, name is key, value is this. Name is role, value is this. In the same manner, this is the name or AI, and the relationship is connected by these lines. Now comes to the how the information is retrieved. Here user asks the question, LLM generates the cipher, it goes through some guard rules, and node 4 execute the query, no, and new 4 returns the row, and that rows pass to the LLM, it gives the answer to the user. This is the whole flow of the GraphDB. So this is the basic difference between the GraphDB, GraphRAG and RAG. I think I have explained more than enough the difference between the RAG and GraphRAG, and why we use the graph instead of the vector search. Whenever we find out the relationship type of the informations, we use the GraphDB, GraphRAG, and whenever just we unstructured type of data, we use the RAG. And I also explain the nodes. Nodes means the individual object in the real world, like employee, department, or projects. And relationships, I already told you. So what are the relationship between these nodes is represented by the relationships, and also explain the properties. Property means the key value information is stored in the node and relationships, and I also explain how the information is retrieved. Here step by step, user asks a question, LLM generate the cipher query, it goes to the new4 GraphDB, it returns some data, and that data is passed to the LLM, and LLM produce the outputs. So this is the concepts of the RAG and GraphRAG. Now I am going to explain the projects that I have built, which contain the simple database like employee, department, projects, and skills. For that, I use the new4j as a GraphDB, new4 as a GraphDB, and I also use the LLM, that is the Grok key. So first of all, I downloaded the Neo4j in Docker. You can see here Neo4j, and it is running on this port, and I logged on in Neo4j database. Now understand the project flow, what I have created. I have created these files. Number one is the seed.py, second is db.py, py, graphdb, and app.py. So what it contains? Seed.py contains build the demo graph in Neo4j. So it first of all it call the get driver method from the db.py. It connect to the Neo4j and delete the old graphdb, create the constraints, and after this build the different nodes, and after that it will create the relationships, and suppose employee has a skills, employee works on the projects, and count node and count the relationships. So code is written for producing this demo graph in Neo4j in these files. Next is db.py. Here we define the Neo4 connections and environment variables. Also define the get driver, means create or verify the connections. Is read only cipher. Here I have written the code which prevents the delete or update informations. Only the selection can be done for this demo, and must start with the these are some constraints like must start with the match, does not contains the clause like create, merge, delete, detach, set, remove, all these things. And after that created the method run query, which runs the query and produce the outputs, and all the reads are executed read mode session. And in GraphRag.py, here we write down the method. Number one is generate the cipher from the questions. Next is guard plus execute on the node4.js, and step 3 is write down the answer from the rows. And next one, these are the methods: generate cipher, write answer, and ask question for pipeline. And this is the main app.py. This is the demo runner, runs into the two modes. Number one is default mode. In this default mode, I have written the 4 questions, and that question has been answered by default. And next is the chat mode. Here you can ask your own question with the interactive way. For each question, it shows the all status: question, cipher generated, rows, answer, and final response. This is the complete flow of the my projects. First of all, run the seed.py file. Next is the app.py file. Here we ask the questions in chat mode or default mode. After that, it goes to the GraphRag.py pipeline. Here it will generate the cipher query and returns the rows and return the answer to the LLM. After that, query whatever is shown in the app.py, this is cipher query, and whatever the rows we returns and answers. And how everything works together, seed.py builds the demo graph in the new4rj. You can ask the question by the app.py, and GraphRag.py converts the question to the cyber LLM of fallback. db.py guards the query and runs it safely on the new4j. Rows are returned to the GraphRag.py, and LLM writes the final answer, and app.py display the empty state to the users. Here we use the Grok LLM, Python as a orchestration, and Neo4j as a GraphDB database. And environment file library, this is a URL of the Neo4j database. User in Neo4j, password is hard coded here, and here we provided the Grok API key. And the model we are using the LLM 3.37 TB billion versatile. If we are not providing the Grok AI, then fall back to the keyword rules, offline rules. This is a whole flow of the my projects that I have developed, and I am showing to the in the code. Here you can check here. This is the questions. This is the show method which will showing the questions and return the answer. And whenever the chat mode is on, here you print the, you write down some questions, it will returns the that question and return the answer. This is the ask method. In this method, I am going to generate the cipher query, returns the query run query method calling, and answer the right answer method. Now comes to one by one. First one is the generate cipher query. This is the definition. This is the definition of cipher. Right answer. Generate cipher. This is the definition of this right answer, and whatever we have written, I am going to explain one by one. This is a Grok key we get from the environment file, and also model from the environment file, and this is the Grok URL, and this is the schema. Whatever the nodes we define here, employee, it contains the property name, the name and role. Department node, it contains the property name, and projects, it contains the name and description as a property, and skills contains the name as a property. Relationship, employee works in department, employee works on the projects, employee has a skills. So this is the schema, just like a normal database. Now this is the cyber prompt that I have written, which is going to the LLM for producing the cyber query. This is, you translate the question into Neo4 cipher. Schema already defined here. Rules, return only the cipher query, no explanation, no markdown fences. Query must start with the match and must only read the never create, merge, set, delete. So here I am implementing some, I am implementing the some, let me tell you, guardless, right? Because we can only read the information and cannot do anything or update or delete on the graph DB. Always returns the name, readable columns, match name can sensitivity with the bit too lower. Examples it has given. Question is which employee knows the Python? So here it is written the match. This is the cyber query type example. Suppose match e dot employee has skills s dot skills where the s name is Python and returns the e name as a employee. In the same manner, I have also defined the relationship here, like who is working on project alpha. So match employee name works on P project where the P name is project alpha, return the E name as employee and E role as a role. In the same manner, which employee belongs to the AI department, match the E employee name works on the D department where the D name is equal to AI and returns the E name as employee, E role as a role. So this type of the question answer I have provided to the LLM so that LLM can understand the how LLM create the cipher query whenever we provide such only the NLP type of normal language, English language to the LLM. So this is such type of rules I have written inside this one, and this is the rule for the writing the answer prompt. Like these rules are already extract the result of database query that returns the question below. Every row is matched by the construction. Phrase them as a plain English answer in one or two sentences. Don't second guess whether the row qualify. Question is this rows from the graph rows. So it will provide the prompt how the LLM provide the answer to the user. This is the prompt. Now this is fallback. Fallback is when we are not going to give the any key of LLM. So this fallback will returns. Now this is the definition of call grok. Here it is we are going to calling the LLM. So this is the method request the post, URL, header, JSON and timeout. It is respond or is for status and return the JSON format of message or content. Clean the cipher. It will clean the cipher query and fallback cipher. Here we provide giving the questions and whenever we provide the questions, it will provide the cipher query like re.match match query किया उसने project से and returns the match e.employee has skills they are this and e works on this projects where the match.group1 return the distinct p name as project, e name as employee. So for pattern template kind in fallback, it is written some another type of the cipher query, and this is the generate cipher query, generate cipher method. Here, if grok key is not provided, it will execute the fallback cipher, and if there is a query, there is a if we provide the query, it will return the call grok method. Here it is this one, and at last there is the ask method, which is called by the app.py on the first instances. Here it is give the questions, and that question goes inside the generate cipher, and that cipher will go inside the run query and provides it returns some rows, and rows of question. These are the two document. It returns the answer, and answer has been returned to the user. Okay, right answer in this way. If there is no grok key, definitely we have to give some methods, dot join value, something like that. So this is the different methods that we have defined for the calling the grok key or without calling the grok key, and also generating some cipher language, cipher queries for Neo4 database. Now come to the db.py. Here it contains, it establish the connection here, find out the graph DB, establish the connection and run query, will find out the driver, and it will run the cipher query language and return the data from here. So I have explained all the files, GraphDB, DB, FDB. These three files I am using in this projects. Now I am going to show you the different commands. See, this is the nodes, like we have now come to the seed.py. Okay, fine. This is the seed.py. Here we gives the data to the employee, department, projects, skills, and here we define the relationships. Has skills, so Priya Sharma has skills Python, Priya Sharma has new 4J. In the same all employee and their skills. In the same work on, Priya Sharma works on this projects. Here clear, it will clear all the database. You can run this query on consoles also. Just 1 second. Happens. It clears all the relationships. Okay. And these are the constraints, like employee name should be the unique, department should be name unique, project name will be unique, skill name will be unique. So these type of the constraint we apply on the GraphDB database. And this is the methods. In this method, it will create the department node, it will create the skill node, and after that it will create the project, it will create the relationships between the all employees or projects, and this is the main method. Here we execute all the queries like session dot, it will returns the how many levels are there, nodes are there. So I am going to create again. Just see the output here. 1 second. Clear. So whenever we execute python or seed.py, So it will return the department number is 3. This is the count. How many department it will contain, how many employees will contain, how many projects, how many skills, and what is the relationship between the, like here we define the relationship between the employee and projects. Here we define this relationship between the employee and skills, and this is the cipher query that make the relationship between the nodes. Now see the output here. Yes, department contains 3, employee contains 4, project contains the 3, and skills contains the 5. See, employee 5, department 3, project 3, skills 5. Now this is the relationship. Priya Sharma has a Python. Yes, we can also see the relationship here. Suppose has skills. See here, Rahul Verma has skills SQL. Rahul Verma has skills Python. Sneha also skills SQL. This contains the Python. So this is the skills works on. Yes, Kavya Nair works in the data engineer, Rahul Verma works on the data engineer. In the same manner, Arjun Mehta works on the platform, and Priya Sharma works in the AI, and Snayer also works in the employee. So this is the relationship, the employee and the department. Now works on which projects? In project Vita, these 2 employee works on. In project Halpa, 3 employees is working, and project Gamma only Arjun is working. So all the type of the relationship that we have defined inside the code here now stored inside the Neo4 database. So it contains all the nodes and as well as the relationship between these nodes. Now this dummy data has been created. Now I am going to run the projects. So for running the project, there is a Neo4 database as I already installed inside the Docker, and it is up and running. Now next one is this one, Python means creating the virtual environment, install the requirement.txt and copy this one, and whatever the credential you can put inside this variable. Now third is build the graph. So I already build the graph. Next is python.app.py. It contains the 4 questions. Just here app.py, where it is, this one, only 4 questions. When we run, it running the question. Now number 1 question is this. It goes to the, say, first question, which employee know the Python? So it goes to the LLM produce the this cipher language, and it will return the data from the Neo4j, and that data is passed again to the LLM, and it will produce the output in this manner. Rahul Verma, Sneha Verma, Priya Verma, here all know the Python also, and you can also inside the graph also. You can see here Python. Where is the Python? Python, yes, Python. Who knows the Python? Priya Sharma, Rahul Verma, and Sneha Iyer, 3 employees. Priya Verma. So it returns the relevant information. So And the same manner, the second question answer has been given. All the coding is written inside in this way, in this show method. I already explained the code. Now come to the, whenever you want to do some chat type of interface like this, minus chat. Now you can ask any type of question, means how many know the Python. This is just a simple normal English language. See whether it can give the answer or not. Yes, it returns the 3 employee know the Python. Process is same. Question goes to the LLM. LLM creates the cipher query. It will execute on the new4 database. It returns the data. It returns the employee count is 3, and that is going inside the LLM, and LLM produce the some augmented result. Now next, how many department contain the AI? There is one department that contains the AI. Yes, you can also verify from the only one department which contains the AI. So you can see here it is working fine. So this is the whole process of this project. Now one more thing I would like to tell you, and I would like to teach you, is the cipher query. This is the clearing the all the queries. Now I am going to create the new nodes which contains the name, this one, name is this one, name is this one. Just here, just put inside here and click on run. What happens? Okay, fine. Create. Okay. Yes, it created the student also and all these data, Charlie, Bob and Alice. Next is create. So this is the uses of create. Now create the course also, course node. So course node also created here. Okay. Now creating the relationship, means Alice students, Bob students, Charlie students, Python course name, match in this one, and also create the Alice enrolled in the Python, Alice enrolled in the new4j, Bob enrolled in the Python, Bob enrolled in the Docker, Charlie enrolled in the new4. This is the relationship. So here I am going to execute this cipher query. It creates the relationship also. Yes, see here, enrolled in Charlie, enrolled in new4, Alice enrolled in the new4j, Alice also enrolled in the Python. So this type of relationship that we have defined, it going to store inside the GraphDB. Now comes to the query. You can do query from the new4 database in this way. What happens? Second. One second. Invalid in what happens? One second. You can do it this way. Oh, shit. These are the queries like in this way. Okay, fine. Matches all the student return the S means students की schema को return करेगा from here. Just here. See here. Yes. Matches the student return the S. It returns the all the this one. So these are the queries we can also execute on directly on the GraphDB, right? Count, display complete graph, all this one, and set you can also update the particular property of any node with the help of set. And there is merge command and there is create command. So difference between the merge and create is that merge will create the new node only when it does not exist. If it already exists, it doesn't create the new one. And we can also doing the aggregation also, like average of is something like this one, and unwind also. Unwind, it explain the plain list into the row, one match per item. Just here what actually it says. Case is just like if as case is same as the we use in other languages. And yes, one thing also important is variable length path, means first connect the student as a friend, means so what actually it contains, I will let you know. One second. One second. Okay. See here what I am going to tell you. One second. student. These are the 5 students. Okay, and we are Alice is student name is this, Bob is student this, Charlie is this, and David is this one. Okay, 5 students. Connect them as a friend in this way. Friend of this one. So yeah, now, Alice is the Bob. Alice is the friend of Bob. It is friend of Bob. So this is this type of the friendship relationship I have defined. Now, if we see the graph, Alice is friend of Bob, it is the friend of Charlie's, and Charlie is friend of the Dave, and Dave is friend of the Emma. So this is the depth of, suppose, so Alice is friend of Bob also, Charlie is also, David also, Emma also. Now understand the variable length variable. मतलब who are the Alice friends within the first or two level? First level पे Bob and second level पे Charlie. We don't want to put this type of this one. If we did like here, just execute this query. Just here. Alice is friend of this one, Bob and Charlie. Distinct. Charlie is Bob and David. Only 3 friends is there. 1 to 2. 1, 2. So it will return the depth of 2 level. Suppose if we provide the fourth, so it will also print the Emma also. And if we write down the only 2, it will return the Charlie's and Bob and David. Alice, Charlie's, Bob or David. So this is depth of up to 2 years, right? And if you want to print out the Emma also, so again if we increase the 3, it also print the Emma also. So this is the meaning of the variable argument. So how many hop or how many depth you want to take for your output, right? So 1 to 2 means maximum 2 relationship it will returns. Minimum is 2. So this is a variable length inside the cipher query language. And example dot py. Yes, this is it. So this is all about the cipher query language. I tried my level best. There are lot of commands, and some of command I execute in front of you, like creating the different type of the nodes, creating the relationship between the nodes, and executing some queries, and some steps like update the particular columns, and merging, difference between the merging, and create merging will create the new node if does not exist, otherwise it will not create it. Delete, you can delete the node. You can also do the some aggregation operation like average or something, right? And wind, unwind, case, variable length path, right? So this is all about the task will and explain the simple graph array system. I am trying my level best. Hope you people like it. Thank you so much. Bye.